So you can't wait to run Skype?
No, my current rotation uses Skype for all the internal communications. Yes.
I can't use Skype from where I am. You should just tell them I can't use Skype from where I am. And when they ask where that is, just say 2023.
Skype for business and even a thing, so.
Ask them if you can fax them your Skype user ID.
Yeah. So it's feel like honestly. I think I'm writing.
I think even Microsoft doesn't want you using Skype, and they own the thing because they want everybody on Teams.
Exactly.
All right, so apologies to those who are stuck outside. I had actually a work meeting running right up to the beginning of class this morning. I'm helping develop some software actually with some people in Switzerland, which is exactly what these distributed version control systems are really good for. So today's going to be a lot less slides and a lot more coding. Yesterday we saw that everybody had was set up. Was everybody able to get into the GitHub repo that I sent out? Anybody not get that? Okay, sounds like everybody got it. So yeah, so you're now collaborators on the main GitHub repo.
Sorry, could you resend the GitHub repo to the Zoom chat?
So for the GitHub repo, you were supposed to send me your GitHub username, and I add you as a collaborator on the repository.
Oh, I'm so sorry.
No problem.
Can I check?
If you send me your GitHub username, I'll add you during the next break.
Thank you.
Oh, okay. Looks like you just sent me your username. In that case, give me just a second. I'll add you right now. QFAN. Okay, Julianne, you should be getting an email shortly to you should be getting an email shortly for GitHub if you haven't already gotten it. Did you get it? Julianne Yang, can you hear me?
Yes, I got the invitation. Thank you.
Okay, perfect. Also, a quick question for you. Do you do microbiome research?
I do microbiome research.
Oh, okay. Yeah, it's actually something I work on too. So just curious.
Cool.
Which lab are you in?
Jacob's lab.
Steve Jacobs?
Jonathan Jacobs, the microbiome.
Oh, okay. I think I'm on some emails with you for a project here on urban wildlife.
You've emailed him on a project on urban wildlife?
It's a big email thread, but I'm one of the people on that.
Cool. I actually, I don't think I'm on that. but
Oh, okay.
so that we collaborate in some way, our labs.
Yeah. All right. So let's get started on this. Today's a lot less structured. There's going to be basically some slides for a little while, but then a lot of it's just going to be us sort of doing collaborative code and seeing how to run kind of a collaborative code pipeline. All right. So agenda day 2, I'm going to cover type hinting. So type hinting, again, is a practice you can do in Python. It makes life a lot easier especially when you're using an IDE. It also makes it a lot easier to share your code so that people know what's kind of expected and what's not expected. We're going to set up a central repository for our work, which, spoiler alert, I actually set that up last night and sent out links to everyone, because one thing I did learn last class is setting it up during class and sending everybody links to their to join on GitHub is not the best thing to do during class. UCLA's email is usually pretty good. Sometimes it takes an hour to actually get a message to somebody. So we're going to review specs for our RPS project. So this is actually saying this is what the project's going to do initially, and also maybe talking about what we expect the project to do in the future. This again is how you design software. Is you figure out what the problem is you want to solve. You figure out what the software is going to do that solves it. Maybe what else it's going to do, after you get your kind of minimum value product out, or your version 1.0. And then that's kind of how you do the design, is you basically say, okay, this is what we're going to do immediately. This is what we're going to do shortly thereafter, and we're going to design accordingly. We're going to split up into teams. So it's basically going to be pair programming. This is also useful because occasionally there are some people who can't really get stuff working on their computer. So I know you almost were in that situation, but you got it working. Lukash, I know you couldn't get some of the stuff working on that computer. So yes, you can program Python though, right?
Yeah.
Okay, so I'm going to have you actually working with somebody as well. Let's see. Yeah, so we're going to start our project container, and we're going to create packages and functions for the project as teams. We're going to review our results today, version 1.0. So basically, class today goes till we have version 1.0 out, which is playing rock, paper, scissors inside of a Docker. And then we'll talk about what we want for version 2. And then day 3, we'll be going over this. So all right, yeah. So yeah, today we're going to learn a little bit more about Docker. Specifically, Docker it's a really flexible system. Lets you run containers, like I was talking about yesterday. So these aren't virtual machines. These are a bit more elastic. They tend to be faster to share and deploy. And so now that we have an IDE set up, we can also use type hinting, and the IDE will start telling us if we make mistakes before we even encounter them. So the first thing I'll talk about is you have your Docker. You're going to be running something in a container. Typically, you need to get data in and out of that container. And there's a few good ways of doing that. One common way of talking in and out of a container is just over, basically you have the container have a sort of virtual network interface, and you can talk to it over a network server you build inside the container. That's actually more complicated because you have to build the whole network server, or you have to at least configure it. Truth be told, the much easier way is you can just mount folders from your computer directly in the container. And what gets written to the folder on your computer goes into the container. And what gets written to the folder by the container is showing up on your computer. That's the much easier way of doing things. So everybody here is sort of bioinformatics or health informatics oriented. Is there anybody here who's not in sort of like biomedical area? Okay, didn't think so. All right, so this is a Docker command that we're going to run. This is one of our first. So particularly if you're on a Windows system, this is interesting because Windows systems generally don't run the BWA aligner. So the fact that we can run the BWA aligner on Windows, if you happen to be using a Windows system, that's kind of interesting. And the command to actually run BWA on Windows through a Docker container. So those who take my workshop too know that a lot of times I talk about sort of the grammar of a command. And just like all commands, this starts off with some verbs. specifically. So you're obviously going to invoke Docker. Docker, again, this is becoming more of a new standard, but at some point they are going to enforce this. You have to kind of give it a subparser, which is basically saying I'm doing container stuff, or I'm doing image stuff, or whatever else, or I'm doing search stuff. So Docker container is what you're invoking. The verb is going to be run. The options is going to be -it, and I know it's hard to see on the screen, but this is --rm. And then here we have a folder on the computer. Here we have a folder inside the Docker. We have our image, and we have the command to run in the image. So this part again, this is a combination of the I and T arguments. And what this just means, I means keep standard input open, which means that when you type on your terminal, it's as though you're typing inside your container. If you don't have that open, then you can't actually communicate with your container. That's actually a good option if your container just sort of runs completely automated. It's a bad option if you actually need to type stuff into your container, or if you want an interactive session with it. So yeah, typically if you're interacting directly with your container, like you're inside of it, you want the -I option. The -T option, you also generally, that one basically keeps the terminal output coming to your terminal. This again, not necessarily all that useful if you're just running fully automated, because the Docker will just log everything that happens. This is very useful if you're kind of running it, at least, even if you're not typing to it, which would require this. This is useful just so that you can see what the outputs are. So this gives you functionally an interactive shell into your container. The --rm option, that one's very easy. That's just deleting the container when you're done.
Oh, just a question.
Uh-huh.
There is some tools to compare Docker image to Singularity.
Yes.
Because when HPC in HPC or something like that, we can use Docker.
So yeah, a lot of HPC doesn't, a lot of systems don't like using Docker because Docker does require privileges, whereas Singularity does not. I believe a lot of these images convert over fairly directly. Singularity came out long after Docker, and I believe they tried to make themselves as compatible as possible with Docker. So, well, I can't guarantee that all images will convert over directly, especially if they're running some kind of privileged instance. I can say that a lot of times the conversion process is pretty easy. I don't remember the conversion process off the top of my head, but I do remember the one time I tried it, it was like, I think I literally just fed Singularity my Docker file and it worked. All right, so this part here, the -V, this is saying mount a volume, and you can have multiple -Vs, so you can mount multiple different folders in different places. But the sort of grammar of this is tell it it's mounting a volume. You're going to give it the host path, so that's on your computer, and then the container path, that's the path within the container that you'll find it at. And as long as your settings are correct, you'll have this folder there where you can just read, and write to it as though it was both a valid folder on the container and on your computer. And you'll actually see changes happening between the two. So that's a very good way to exchange data between your computer and your container. And the nice thing is, especially in bioinformatic operations, this is really the most common way I see people moving data on and off their containers. All right, next part, this is specifying the container we're actually using. So the way this works, we're pulling from the biocontainers image library. So biocontainers is kind of a consortium that makes containers specifically for doing bioinformatic tasks. They generally tend to run pretty reliable stuff. From within biocontainers, we're selecting the BWA image. And the colon just means the version, which is latest. So we're basically saying pull down the latest BWA image. So essentially what it's saying is go to the biocontainers repository on Docker Hub, pull down BWA, just pull down the latest. Once you've developed kind of a fixed bioinformatics pipeline, or once you're starting to use these things as part of a production pipeline, you should basically do a search for anywhere that the word latest comes up in your Docker invocations and remove that. Because the problem is latest is whatever the latest happens to be. And if they update versions, maybe to something that is not fully identical to the previous version, gives you slightly different data, you could actually switch which version you're using in the middle of the pipeline. What you use next week might be different than what you use this week. So that's where you want to actually go on there, figure out which specific version you want to use, and just pin it down to that version. All right, and the final part is a command to run inside the container. Since this is a Linux container, most Linux containers, you can get an interactive terminal by just typing in /bin/bash. And so if we go into this container, we could actually cd into data, and that would be in this folder on our computer. All right, and version control system branching. This is actually something really good to get a handle on early once you start using version control. Most people, it takes a little while if they're kind of learning it themselves. There isn't what I would consider a right strategy or a wrong strategy. Yeah, like I said, there isn't really a right strategy or wrong strategy. There's just a better strategy or a worse strategy for your usage case. So a couple things to ask when you're planning this, though. Number one, how critical is the system that's involved? In other words, what's going to happen if you put in a new change and it starts breaking stuff? Is it that you're just going to be slightly inconvenienced by having to fix it? Is it going to maybe, trash an experiment, or is it going to maybe stop productivity for a couple of days for several people? Or maybe if you're working in a more clinical space, are you looking at a scenario where patients are going to actually face potential misdiagnosis? And I see cases where people are messing with stuff where they shouldn't mess with, and there's a lot of systems in clinical labs, for example, to prevent people from changing things that should not be changed lightly. Other things to think about: how many people are working on this project? So is it just you and maybe a couple collaborators close to you? Or is it going to be like your entire field uses it? Or is it going to be that it becomes like a standard bioinformatic tool for research? So just an example of this, and I'm going to pick on Julianne since she's online and also works in microbiome. I actually write microbiome analysis software, and I have one piece of software that has actually seen fairly widespread usage. So the way that I need to handle that repo is going to be different than other things, especially now that it's out and I know that it's doing that, because I really need to make a version 2 of it. So so think about how many people are working on this project and how are they distributed. Is it easy for you guys to meet in person, or is it more a situation where you have collaborators all over the world keeping different hours? And then next question, how will this be used and distributed? So is this going to be something that just runs as a web service where people are just connecting and nobody ever actually downloads the version? Or is it something where people are going to be constantly cloning and pulling your repo and running it on their own systems? So all stuff to think about. So for common branching schemes, there's just this one where you basically have one branch and you just go version 1.0, version 1.1, version, or version 0.1, version 0.1.1, version 1.0 onto version 2.0, and it's just basically a straight line. This can work if you're kind of a sole developer on a project, but even projects where I'm sole developer, I don't do this. This is generally considered a bad practice for a few reasons. So the one that you'll typically find me using is something more like this, where I branch whenever I'm doing any significant change. So sometimes you will see me just go directly from 0.1 to like 0.11 on main. And the reason for that is like I just fixed a typo or something where the chance of it actually affecting the code is pretty much minuscule. For pretty much any change where I'm altering the functionality of the program, though, you'll see me actually make the change on a branch. I can test on the branch, and then I can pull the branch back into main once I'm happy with it. Number one, that makes sure that the main version doesn't have any sort of code that's still being built in it. So everything in main is stuff that's already built and tested. It also makes sure that if, for example, I introduce a bug at this point, I can actually trace the bug back to this point and say, okay, this branch caused the bug. What do I need to do to undo that error? And whatever changes happen on that are basically traceable back to that branch. So this is kind of a strategy called experimentation and feature addition. Occasionally you might say like, oh, I have an idea for version 2.0. I tried that idea and I realized, okay, that idea was actually a bad idea. And basically I just prune off that branch. I just say, okay, that branch never existed, or that branch is basically going inactive. I'm just keeping it around for records in case I ever have that dumb idea again. The other thing you can do is you can also just do some build outs here. So for example, you have version 1.0.0. Maybe you get a couple people using it. Somebody figures out there's a bug where it doesn't work on their system anymore. And you can actually branch out, fix that in version 1.0.1. But you also have another branch going at the same time for version 2. That's also a really common strategy, so that you can sort of have major changes and minor patches running in parallel, and they don't start bumping into each other, where you have like version 2 code making to version 1.1.1. This is the stable development strategy. You will never use this if you are the only developer, or if you have a tiny team, because this is a pain in the butt to maintain and implement. Usually at this point, if you have something like this, you have somebody who is like the DevOps person and the official administrator of the code and all that other fun stuff. You've also probably published it, and it's probably something your lab is getting funded to maintain at that point. But you can kind of see here where this is a very complicated scheme, but you'll notice here that, for example, you have your production branch, and this is typically a very protected branch. There's only a couple people who get to push to it. You have your staging branches. You might have a staging branch, I should say, and you also have development branches. You might have actually multiple development branches, like you might have one per developer or one per project. And then you have these little individual portions of these little individual projects actually contributing on the development branch. When something on the development branch is ready to be merged into to being in production, then you'll see that portion get merged in. So let's say these two projects completed a new feature, that goes on to staging. And then maybe they do something else that goes on to staging. And then at some point they say, okay, this thing needs to be merged on. So maybe they're on a cycle of just every 2 weeks we update. Or maybe they say, as soon as we hit these, as soon as we've hit these marks or decided we're not going to hit these marks, we update the version. So at this point, there's going to be some kind of testing involved to make sure that everything still works properly, especially the core functionality. And assuming that testing is passed, then that gets merged into production, and that then becomes the version of the software. So if you're running something like continuous integration, continuous delivery, you'd see that basically once you push a new version onto production, there's automation that detects that there's a new version, and it starts reimaging your web servers. Alternatively, this might just be something more like Chime, which is a big microbiome analysis package. This might just be pushing out a new version on GitHub, and that's all that happens, and people kind of pull down the current version. All right, and type hinting. All right, so type hinting, basically it does exactly what the name says. It makes very clear what types you should be getting passed and what types you should be returning from a function. Python interpreter does not enforce this, so you can put in type hinting that is completely apropos of nothing and makes no sense. The Python interpreter won't care as long as what you put in. So it'll care if your type hinting is valid, which is to say that your type hinting reads as type hinting. It doesn't care if your type hinting is correct, which is to say that whether your integers are all integers, it doesn't care about that. It just cares that the type hinting is readable as a type hint. If type hint's not readable as a type hint, you're going to get an error because the interpreter's like, I can't make sense of this. So yeah, so what we see here, we have a function definition. The role of this function is to rickroll somebody apparently a bunch of times. So we're going to pass it some text, which is going to be a list, which here we're saying it's going to be a list of strings, and this is how you tell it is getting a list of strings. You're also going to tell it the number of times to repeat the thing, and that's going to be an integer. And that's going to return a list of strings. So it's basically just going to repeat the thing over and over again. Here we have the list of strings, and here we have the number of times it repeats. And here we're just calling the function the right way and the wrong way. And you'll notice here that where we pass it the list of strings here and the integer here, we don't really see anything special. Where we're doing it the wrong way and we've passed it an integer and a list of strings where it should be a list of strings and an integer. So we've reversed stuff, which definitely happens a lot in coding. You see here that it's highlighted them, and actually in PyCharm, if you put your mouse over the highlight, it'll even tell you, hey, I was expecting this to be a list of strings here, but you're passing an integer. And again, the Python interpreter won't immediately flag this, like it won't crash when you start trying to run. But as soon as it's trying to iterate over an integer, anybody ever see what happens when in Python you're trying to iterate over an integer? Anybody know what Python does when you try and iterate over an integer, like for I in like for line and this thing actually comes in as 6? Anybody know what that does in Python? It makes it crash. You'll get back an error basically saying that, hey, you're trying to iterate over an integer, and integers don't have iteration methods to them. That's actually a better outcome. What's an even worse outcome is if you pass it something else that can't iterate, but isn't what you think it is, because then you have a much deeper error to fix and a less obvious one. So this is where type hunting really pays off. The other thing is, if for some reason you were to pass this function along to somebody else who wants to do it, they'd immediately know what kind of types are expected as well. So again, if you look on this one, it'll say it was expecting an integer, but it got a list of strings. So basically it'll tell you everything that goes wrong. All right, and today's coding. So we're making the rock, paper, scissors program. First thing to do whenever you're writing a program is figure out what the program is going to do. Also start figuring out figure out what the program is going to do immediately. Also maybe figure out what the program is going to do later. Also start thinking about what the program is probably never going to do. So that if somebody asks if the program can do that, you can tell them, no, I'm not going to do that. Because people will make requests, and occasionally it's better to just be prepared with an answer like, nope, that's too hard. So for rock, paper, scissors program, what are the possible outcomes of the game? And what triggers each one? And most importantly, how generalized and flexible can you get the data algorithm to store it or to sort of support it? Also think about, how are we getting a player's throw? How are we getting a computer's throw? And what do we need in our environment to do this? All right, and so tomorrow we're going to add more features to this, but today we're going to build this out. So the rest of the day is basically coding. We're going to break into pairs. And yeah, I can already see that, like, basically it's going to be you two, and then I think you and Lukash back there. And I guess you two in the back row can work together as well. But I actually should ask, who considers themselves already fairly strong in Python? Okay. That should work. Okay, so if you haven't already done so, you should be able to clone the repository on your computer, because you are a collaborator on the repository. So if you haven't already done that, go ahead and do that. If you haven't accepted the invite to be a collaborator on the repo, just accept that invite, and you should be able to clone it down, and you should also be able to basically start modifying it and be able to actually push back up.
My first name 99.
All right. LUKASZ 99. Okay, let me know if you get it.
For writing the code in PyCharm and then.
Yeah, you can write the code in PyCharm, and then you can basically, yeah, and then you'll update through Git. Yeah, so you two might want to move closer so you can work together. The other thing is, remember, whenever you do your changes, make sure the first thing you do when you pull down the code is create a branch. Yes?
We need one branch for each.
Yeah, each team gets one branch. Because what's going to happen is you're actually going to then, you'll then push your code back up. And we'll actually look over the different branches to look at different people's code and figure out who has what, and maybe how we integrate various parts. Also, just to, if you do get stuck or if you need kind of some ideas of how this project is structured, if you go to the repository and you go to issues, so it's going to be one of the buttons towards the top. If you look in issues, you'll see that there's actually repos from other classes on there. And there's also just an example repo for day one. And that'll give you some ideas about how to do it. So one of the first questions I'll just throw out there so that everybody can be roughly on the same page is, what would be a good way to track kind of rock, paper, scissors outcomes? Especially since I said yesterday that at some point we're going to extend it to rock, paper, scissors, lizard, Spock.
We need track out.
So what would be a good data structure to kind of track the game? Or what would be a good state? So like, we know that in rock, paper, scissors, rock beats paper, right? Or does it? Paper beats rock.
Yeah.
Yeah. So we know in rock, paper, scissors, like paper beats rock, rock beats scissors, scissors beat paper.
I just have like a list of pairs.
You could have a list of pairs.
A dictionary.
I think a dictionary might be a better option. So there's two things we need to do. One, we need to be able to very quickly get a list of what the possible throws are, like rock, paper, scissors. What would happen if we had a dictionary of lists, or a dictionary where the key is a throw, and then the value is a list of what beats it.
Yeah.
Because again, you have rock, paper, scissors, lizard, Spock. So you could have multiple things that either it beats or that beat it. And unless two people throw the same thing in any of these games, in which case you have a tie, you never have a tie.
Right.
So yeah, so that would seem to be the logical choice, right? And so having that central data structure, does it kind of come together now how the program might work around that central data structure? Yeah.
So it's
Yeah.
Okay, and Julianne, you're kind of on your own for this one, unfortunately, because well, you're the only person online. Usually I have enough people online that I can sort of combine teams online as well.
I guess one of us would do that, and then someone.
All right, so I'm going to let everybody kind of build up their programming, their sort of coding flow. So it's 9:40 right now. I'll check back in with people at 10 o'clock exactly, but throw up a hand if you have a question or if you have a good idea. We'll check back again with people at 10 o'clock exactly and see how everybody's doing, because that's a good time to start exchanging ideas and maybe start looking over people's and maybe see how people are solving problems, and then we'll get back to it.
Yeah, I know. I don't think I just. So, yeah. Now you can see it. Do you know what color? Okay. Well, maybe, yeah.
So basically.
Yeah, that's like. Yeah, I think.
Yep.
Do we have to write our code in the commit.py file, or is that something?
No, so, did you take the advanced Python class?
No, I didn't.
Okay, so that's actually how you initialize set of Python packages.
Okay.
So for example, if you look at the, if you go back to the repository, or if you go back to the example I put up,
It's a biggest switch.
you go to issues. Actually, I'll just, yeah, and then, yeah, click on that. If you open those, and you can actually see how it's okay. So if you go, yeah, you go to RPS, you can look at it. Okay, so there's, yeah, all it is doing is just importing, it's just importing database, or it's just importing Python packages there to share with the folder above.
Okay. Right.
But yeah, that's a good technique to get into though, is kind of building. If you can kind of build a hierarchical structure, especially if it's more complex. That helps keep your code organized, because you'll notice that like all the files are based, all the functions are bite sized, and all the files you can probably print them on a single page. So it helps keep your code organized and sort of concise.
Just like that. Yes. I think we're sharing. So we made a branch, but I'm trying to push into the, I mean, they're just trying to push the repos so that we have access to that branch. So I think right now we're in that branch, but when I try to push it, it's down to I get this error here. So that
Oh, yeah. Yeah, you might, if you get an error saying password authentication doesn't work, that's because GitHub requires token authentication. You can fix that by going into Well, so number one, this would be easier actually to do. I'm gonna actually recommend not doing it with the command line. I mean, it's good to learn how to do that, but honestly, it's much easier if you're if you do it either through like your IDE or if you do it through the desktop app. There are ways to set up your authentication on the command line, but they made it a lot harder because they've really beefed up security. So yeah, that's one of the reasons I recommend the desktop app, is the desktop app will actually sort of just automatically do the authentication for you.
Or actually, no, you don't have to make an end on that.
Yeah.
Something I will say, previous mainly easier to just do it on a computer rather than trying to maintain one branch. You might actually convert conflicts into the branch. Okay. So, yeah, it's usually easier to run on one computer, but you can definitely do it on two, it's just that'll work as well. You just might run into more branch conflicts that way.
Yeah, it's about storing.
Yeah.
This is. Yeah. That's gonna be in branch, like we'll put it on branch. Okay. Yeah, like, that speeds this. Oh, yeah.
Oh, sometimes there's a function where.
But then we also made like a with that. Yeah. Oh, like, oh, yeah. Cause like you wanna basically build it type like rock. Like, so maybe this.
Working with the top of those. Sure. Yeah, just clean here. Okay. Yeah, so the main thing is, just make sure that you're making your changes on a branch rather than on main. Because if you're trying to connect directly to main, I will take that back out. Okay.
In the yeah. So I know just okay, so just need first to yeah, I guess we'll have I guess the person and so like we'll throw and you won't hear but also so not the person. So I guess the leaders should be random should be and then when we compare those we probably just yeah. Yes. So if I throw scissors, there are someone else to respond. Then I just say like in mine, if rock is scissors, sorry, he is I put the one camera for
This was pretty easy. This one works well.
Oh, are you looking at a picture of weapons?
I actually seen a picture of myself teaching. This is like one of the pictures you actually take in your class. Oh, so.
Sure, I am not in a setting, but yeah, it's whatever.
Okay, that's fine. I'll leave it on like full auto anyway.
And then so we want to be able to yeah. Gotta be ready. Yeah. Oh, you want students in the
No. Okay, there's also a Zoom right in front of the right. Yeah.
No, I don't. I think. Yeah, it's especially good.
Hmm?
So I think it's not especially good.
Yeah, I know.
That's with that.
Oh.
And that'll be.
Yes.
Okay, so get some more light on you in the front. That was just. Really better. It's just.
Actually, I should probably just keep it on like this for the class anyway, because we're not really using the.
Yeah. Yeah, see you a little better now. What do you want? Just. Or do you want to be more in the center?
Sure. It probably should be a little bit more in the center, but that's not too bad. Okay.
We could, yeah, no, I know. We, I'm just trying to be rigorous. It's the problem is if I go too far away, then you're just like.
Yeah. You can always zoom out.
It's true. Or you pull it 5 years. And then there's a main dot. You like this better? This is gonna be.
Yeah, that works. Perfect. Thank you. Hmm.
Oh, we should in a while.
It was like you better than self.
Yeah.
Just don't always have it with you.
Since you work for.
Yeah.
I have a T-Con plate reader, like not working until we finally just disconnected it from the internet.
Really?
Yeah, we had to, we don't know what was going on, but we had to keep, restarting the computer, or at least like go in task manager and cancel the program after a single plate run. I mean, otherwise it just will stop.
What's an old plate reader?
What?
Is that an old plate reader?
Oh, it's pretty new.
Oh, which lab is this in?
Orange Shear High Lab. I don't know when we got it exactly, but it's.
Okay, is that a lab you rotated in or?
It's 11.
Oh, okay, cool. What does that lab do?
So it's like a mitochondrial biology lab. That's kind of focused on metabolism. So kind of our main projects are working on adipose tissue, and so we specifically like looking at mitochondrial lipid droplet interactions, and then we also do kind of
White adipose or brown adipose?
brown typically.
Okay.
With like really nice large lipid droplets, but also not just like solely lipid droplets. But we do a little bit with the white, with the Y as well.
Okay. Which department is this in?
So he's technically under the med school department, I always forget. But it's in like CHS and South Tower. Second floor. So yeah, Orient's, he's the head of the metabolism team, started back in the. And then we do like crystal structure, ATP hydrolysis by complex 5 now. Yeah.
Okay, is the PI MD or PhD?
He's both, but he doesn't practice.
Oh, okay.
He was never really in it. He was like an MD for a year and decided to like practice.
Okay, which department is he in medicine or which division? I'm guessing your lab also has like a seahorse and stuff.
Oh, we are, yes, we are for all respirometry. So we have.
Oh, okay.
5, 6 seahorses in the lab, and then we have an imaging core as well. That we run, so let me do quite a bit.
You guys-
endocrinology is just
Oh, okay.
So I used to do a lot of like on diabetes and mitochondrial metabolism like so
Nice. You doing any looking at this is probably more outside the cells than you care about, but like the role of LPL or GPI HPP1?
No.
Okay.
Right. In this folder,
Those are the things that get those are the things that get the lipids into the cell.
Yeah. But like I said, we're mostly looking at in relation to like regular metabolism, like fatty acid metabolism, and like beta oxidation and interaction. That's not like you can do this.
Yep.
So then what you can do.
Yeah, it was actually one of the early people who helped discover GPI HPP1. Like all the early papers that you'll see my name on them. All right, so we've hit 10 o'clock, so we should probably do a quick check-in to see how everyone's doing. So, oh, by the way, do people like it better with the lights bright or with the lights down? Okay, that's kind of what I guess, because you can still read this pretty well, even though I know the bulb's kind of failing. All right, so first question. We need to maintain some kind of a data structure that basically defines the game in terms of, what are the possible throws and what beats them or what do they lose against. So for each group, why don't you say how you made that data structure? So what, you don't have a data structure yet, or? Okay, what would you have for a data structure for that? Okay, so it'd be a dictionary, and what would be the keys? The different throws, and what would be the values? Okay, so that sounds pretty typical.
Yeah, we did that.
What beats the throw? Okay.
Yeah, we did the same thing.
Okay, and you guys?
I don't think we really created a data structure. What we just did is we put a bunch of if else statements, like if the computer says that this, if it like one, if the computer puts this outcome and you put this outcome. Like,
Yep.
So on.
Okay, so one of the advantages of so remember how we said that we might extend it out to rock, paper, scissors, lizard, Spock? So one of the advantages of having a data structure rather than just a bunch of if else statements is it becomes much easier to add to a data structure than to keep building if else statements. It's also typically more efficient to go through them, although at this scale, you'd probably never notice. Okay, so we have that. For the people who don't have a data structure yet, do you have a very clear idea of how your program is going to go? Not so much. Okay, for people who do have a data structure, do you have a very clear idea now of kind of what your program is going to look like when it's built? So that's, I think, the number one trick to getting to sort of building a good program. And again, this is something that isn't just my philosophy. This has like been validated by a bunch of other people, including the guy who wrote Linux. Is if you start off with a focus on kind of like what are your core data structures, and you build around that, you tend to have a much clearer building pattern, a much clearer idea of what you're going to build. So your data structures kind of define your code. Your code doesn't define your data structures. So there's a kind of way to think about it. In other words, you know what's going to be in your computer's memory, and you're just writing stuff to make that go to work for you. You're not in a situation where you don't know what at any given time, you always know what your data structures are, rather than you just have these things being built up and taken down. So, okay. All right, so now might be a good time to maybe start looking at the code. So if people want to push up, have people already started pushing up their branches in their current state?
Yeah. Oh, yeah.
All right, so I'm going to put GitHub up here. I'm going to go to code. All right, so We have the Michael and Quentin branch, which I believe also gained some additional people. We have our RPS support. What? We have not made a Docker container yet. We're going to actually work on the Docker container a little bit later. All right, so first thing is the requirements.txt. So that usually wouldn't go in this in the support folder. This would usually go at the top level.
So would that be like in the main branch?
Not the main branch, but it would be in the main folder. So you would actually have the requirements.txt in this folder. The one that contains RPS support. That's easy to do. Yeah, you would just move this one up a level. For playgame.txt or for playgame.py. So we're importing random. That's an obvious thing to do. We have our rule dictionary, which defines a game. That's cool. We have this while loop and basically a while true loop that'll run forever. What?
Until someone wins, I guess. Yeah. Yeah.
Okay, yeah, or you can do it till someone wins. So. Okay, so yeah, we have player throw, and that's going to take in, yeah, that'll work. We're getting the computer throw. We're printing what the computer threw. Yep, we're checking to see if the computer throw is in there. So yeah, this dictionary says this dictionary basically says what it beats. Yeah, that's legit. That's fine. So you have only one issue with the logic on this one. What happens if the player and the computer both throw scissors?
Would that go to that else? Throw again, and then since it's a while, we'll just take it.
Okay, yeah, okay, never mind. I see what you did here. Okay, that makes more sense. Okay. Yeah, so okay, so you have that covered.
Yeah, so it'll only break if there's actually like if someone actually wins. And then
Yep.
Not.
Oh, because.
Oh, yeah.
That's a good way of doing it, although a couple things that you are missing. Typically in Python, you'd want to have that as a function.
Yeah, I think.
So you probably want to move some of these things to functions and probably have it actually return just, player win, computer win, or tie or whatever. Because keep in mind, again, you want to be able to extend these things. If it's just built like this, then it's going to be very inflexible. Okay, not much to see in there yet. Okay, it looks like you guys are the ones who've actually committed code so far. Okay. So typically the way this will work is we get something up and working. And then usually after class, I'll kind of give it a quick go over just to clean it up so that we're ready for tomorrow. So you'll be able to see the kind of modifications I make so that it's ready to extend tomorrow. But yeah, so far you guys are pretty much on the right track. I would clean up the code a little bit and probably put it into functions. Also, if you notice in Python, you have a you would see in these ones, but like you have if name equals main, that with the dunders. You wouldn't use that for those support packages, but you would use that in your main package. But the big one is, yeah, you should have more of those things doing returns, because right now you can't, because none of that stuff is in functions. If you import that package, it'll just run. So yeah, you're on the right track, but move stuff to functions. That way you can reuse them, and you can also just call them from elsewhere. You will probably need to ask for help.
Yeah.
Otherwise, well, what was going to be your idea for getting the players throw?
Yeah, I was thinking just sort of like ask for input, type it in, then it would.
Okay, yeah, you could ask them to type it in. The only thing with, if they're going to be typing in rock, paper, scissors, make sure you can handle different capitalizations. Yeah, the alternative would be build up some kind of, on the fly, build up a dictionary of rock, paper, scissors, 1, 2, 3. And you just have it so they can enter the number.
Oh. That's after my house, that would, make it so they can't even eat that.
We need to integrate it later. Like I said, otherwise that was just maybe something like
Like, but it's just, I would just.
All right, I'll check back with you in a few minutes, but definitely raise a hand if you have any questions.
Yeah. The way these outside of the white player, and when it's because we have to every solution model has to throw again. So maybe to go away, but sure that's very good. And function that goes is or like a case or okay, so I guess they could spell it.
Because I have reached the more credentials. Oh, okay. You'll have to look up how to set up a next day. And then, yeah, we're just
they're growing now and line together.
Yeah.
No, it's like you have to get the pull and then we already have the and then
Yeah, the other thing you can do is if you go into your site chart setting, you can actually set up a connection to GitHub on there.
Oh, yeah, there's like. So then you can, then it would run this.
Oh, yeah.
You gotta pick off.
No.
Okay. So we're trying silver and one, so we're trying to just get it getting wrong.
You think that's like-
So,
I'll give it this notice.
yeah, I think we're up to two will look over grids. So what's gonna happen next is I'm gonna pick somebody version. The one that's like probably closest to being what we want is, and then we'll figure out, but potentially it's close. What's gonna happen is we get that version, we'll figure out, we'll go with that and then,
Seems like we're turning.
I just want to.
Or something.
understand this.
Okay.
The June we go on.
This. So that we're not taking-
It's like how we.
Oh, you're watching the phone here, right?
Yeah. So.
I run into more than yesterday, yeah. I was in a lab, it was in the clinical microbiome lab, talking about skin beat just in the grad.
Like when we're passing it up, the keys.
Well, that's dangerous.
Yes. So it was specifically, it was for them and for basically people that you're talking about.
Yeah, this is it's like with what? Is the service that I was.
Oh, okay.
Yeah. But I say bone marrow is a lot bigger. It's at least half the service, getting a transplant or,
I think this, it's.
uh.
Oh, yeah. This is true.
Well, yeah, I have 2 hours.
Oh, okay.
Yeah, so, yeah, it's just a series of just getting gonna get your stuff because. Yeah. Things going on.
Lizard, I think lizard means.
Oh, really? Yeah.
And I'm one of the small percentage that, well,
Oh, you don't have it?
I have excellent veins, no CMV and a typo.
Yeah, I'm O negative.
Worry about that right now.
So I'm like,
We made it empty, so we don't. Right?
I get called all.
Yeah.
I don't know about my CPs. That's great that you can then see me negative.
So if you CMV negative, they let you know. Believe me, they let you know.
They let you know, okay.
They really let you know, so
Yeah.
they don't let you forget.
Yeah, I mean, you should donate. I mean, there's like studies that like for men, it's actually healthy. If you don't like lose your blood every month, and stay build up. So I guess.
That actually- Yeah, I know. That's actually one of the reasons why I was. It turns out like you're probably supposed to see somewhere anyway. And if you don't, red cells, building new red cells.
Right, so totally, so you just clean it out and then just stimulate your marrow to make more red cells.
Yeah, and it's actually a little extra cholesterol.
These are extra cholesterol.
Yeah.
It's funny because men are always like the more squeamish ones, but like, you know, it's totally good. There's actually a study that showed that like, can be good. But obviously.
There are, but I'd be actually surprised if it's not decreased cardiac risk, because have you seen studies where thalassemia patients, I mean, those basically thalassemia patients are always losing red cells.
Yeah.
It confers with the vaccine.
Like they, yeah,
I don't think they never get heart disease,
yeah,
but there is like an observable protection.
okay.
Always wins.
Yeah.
Did I take that from you now? You just gave her me.
They let you take doubles from me, and if I do the platelets, they let you.
This is.
Oh, wow.
Okay, so.
They take double breaths.
So it's,
Give you that very small. Like my leaders. But if you want.
Or is it looking like?
Yeah, I also, possibility in the center.
We're saying if-
Oh,
One time I went to donate, like, I was, especially when I was here all the time, I was like, and basically, in the center, I was like, oh, this place is every week.
oh, wow.
Like, I said, we really let us be bigger.
That's such, well, I know, because every time I get order platelets or anything for these blood notifications, that's always a see a dictionary.
Yes.
Yeah. And irradiated, I always do. Which you shouldn't, I should look up their CMV status, and if I see what positive, it's fine to.
we do-
Yeah.
Yeah,
Well, the other thing you never know, straight food has.
yeah.
I guess they could.
You know, they do have-
Yes.
Big one now is
I guess. Right, right, exactly. It's always put CMV negatives. That's gotta be rare. Where do you donate? At the one in the center, just right here.
Yes.
Okay, next to the meat shop.
When I was donating weed, people brought a weed shop, yes.
It's like a weed shop now.
Yeah,
Yeah,
no, I walked by there. Oh, weed shop?
Yeah. yeah, yeah, I should go do it. Yeah. That's amazing.
They want, so I was donating with the weekly, and then one time I went there donating with week. And the person, you know, they do usually thing where they stick, you know, they put my finger, they stick and she gave me a shot. You can't donate to that.
Oh, really?
That's like, and I think it's exactly what.
Yeah, well, because those are like random number generators. That you give.
Yeah, kind of. They're graded number generators, we usually live like a reasonable rate.
Yeah.
But I was like, I think it's.
Yeah,
And she said, no, it says your hemoglobin is like, it says you're like an 8. And I was like. I'm usually like 10.5 or 11. I'm usually 10.5 or less to be accurate on me, like red cells.
yeah.
So if I drop down to 8, if I actually drop down to 8. Then I probably should be actually go back to the hospital right there.
Yeah, kind of.
I was like, on the other hand, is it also possible that the computer may be wrong?
Yeah.
I mean, you should have a bubble there or something. So no, it's like you're. And I was like, all right, about 15 minutes, I finally got it. I finally got it, okay, let's try this another message. I put my finger and drop in the green stuff, the copper sulfate or whatever. And let's see what it does there, see if that agrees with the so if this is real, then you probably should go see a doctor.
Yeah.
She pokes it, she like pokes my finger, puts doctor, oh, that is fake at the top. I was like, can you try the heat again? Puts it in the heat, he's like. He comes back with she is it like, okay, yeah, you're right.
Yeah, you would be pretty low.
Yeah. The funniest part was like, at that point, the supervisor walked in, was like, and was like overhearing us talk that, this guy, no, he's not though. Like, just look at it, if the machine says he will, the machine's probably. Wrong.
Yeah.
Yeah, I just see you right.
Yeah. What do they give you for job?
I don't know, I haven't actually done it in a while since I'm not. I guess I'm still getting into the thought, you know, it's so many different voices now. I don't think it's. Yeah. Yeah, I get what it is.
You do what? Yeah, they do. They actually pay you. No, I don't think they pay.
Okay.
Saves.
Older, just stays everything. Yeah, it's looking at it, but not bad. I did some on campus teaching, it's not on campus. I have just like.
My job was nice.
Yeah, dear, it's like. Especially like. Sounds like. Yeah, I'm a city called Parker, so. So yeah, we're at this, we're in like a hiker. I actually don't.
So pretty.
Yeah.
Like I know you can like maybe. Sounds like.
I don't get out there. That is my, it's just something about it. I love using it.
Yeah, it's wrong.
It's like, you can make it well.
What's the medication? I'm not getting.
Yeah, I think.
That doesn't work for two things.
It's you out and this is.
Everything.
Oh my god.
I feel like, well, now you're just a little bit box with all the pharmacy.
Oh, really?
Yeah, you can just pay 95% off. But yeah, I know it's something. I know South America is one of the things that give you South America, you're take out the really.
Oh, really?
So it has.
Well, that makes.
Wasn't actually working.
All right, let's do a quick check now.
Yeah, I did.
Oh, and I see a question there.
So we just. Yeah, guys, yeah,
All right, so I have a question online, which is how do I know what to put in a init.py? So typically your init.py is just going to be, it's just going to be importing your other packages it's going to be importing the other code that's in there. So typically your init.py is just a bunch of import statements. And Julianne, if you look in the issues tab, you'll notice that there's links to previous projects in there, so you can actually kind of see how the previous projects were structured. As far as putting the requirements.txt into the sort of main folder, so that's just kind of done by convention. You can, in theory, put that requirements.txt anywhere. You just have to know where it is so that you can tell Python package manager to install those. But by convention, you typically put that in the top folder because that's where people know to look for it. All right. So let's reload this one, see if there's code here. All right, this one has just been pushed to. Okay. So this one's looking pretty good. One thing I would say is for type hinting, typically you want to type hint both what's going in and what's coming out. What?
Because we have a none type and a string. Yeah, depending on if there's a tie or if there's.
So would it maybe be better to just have all your outputs be strings, and maybe if nobody wins, you just return an empty string? Yeah, that's actually one other nice thing about type hinting is it kind of gets you in the habit of making sure that your function will always return very well defined type. So sometimes you do have functions that, you know, maybe do need to return different types. But keep in mind that then if your function, if somebody else uses your function, or in fact, when you use your function, you're going to have to check to see what it returned, right? Like you're not just going to be able to assume it returned a string. You're going to actually have to check and make sure it returned a string. So yeah, typically it's better to try and have your functions, if at all possible, just return one type so that whatever somebody does on whatever it returns is going to be consistent. So yeah, you could type hint that out to string. I will say that you can also type hint the return as a list. So you could actually say that the return is a list, or you could say the return is, and then in brackets you put none or none type and string. But in this case, I think it would be way easier for anybody using this to just know that they're going to get back a string, and the string will either be player with a capital P, computer with a capital C, or or to return like maybe an empty string or whatever. The other thing that might be helpful is sometimes you want your functions to be silent. Like maybe, yeah, so like maybe in this case, it might be better if instead of this function saying who won, like this function will decide who wins, but for actually reporting who wins, maybe a function outside should do that. Because, for example, if you wanted to make this into a web server, or you wanted to have it output somewhere else who wins, maybe the other function can decide that. But otherwise, yeah, you're pretty much on the right track with this. All right, we have a function to get CPU throw. We have a function to get player throw. We have a main function here. Yep, this is pretty good. The only thing I would probably say to change about this is your main function is getting quite long. So you might want to break that up a little bit, especially because it's doing several different things in there, right? So it might make sense if you're going to keep score to keep score in main function. But you could definitely at least move out the part that's checking to see who won to its own bit of functionality so that you can actually call it rather than just have it be the main function. This, by the way, is exactly how it goes when you're designing program. Is typically, you're looking over different submissions and being like, okay, this is cool and you're on the right track or whatever, but it needs to be a little bit different, or it needs to conform to these standards for like reusability. So this is like typically how the process goes when you're building as a team. The other thing is everything for this program, obviously it's not a huge issue because rock, paper, scissors is relatively simple. But a lot of this should probably be kind of in the support package rather than just in the top level. Again, this isn't a very complex program, so here it wouldn't make a big difference. But once you start getting into more complicated programs, typically you want something a little bit more hierarchical to have the code more organized. Okay, we have a main. We have a play. Oh, whoops. Okay, yeah, I am there. All right, so the one thing I would definitely say about this is for your data structure here, because really this thing defines the game and it defines how you can extend it. Do you need to separate between beats and between what it beats and what it loses to in there?
The other people did it, they just use such brackets.
They made lists.
Yeah.
So
Okay.
yeah, and actually the truth of the matter is it's much more efficient in this case because you know that there's only 3 possible outcomes to a game. It's win, lose, or tie. The only way to get a tie is if what the player throws equals what the computer throws. So that's very easy to detect without even looking in there. And then as far as figuring out what beats what, you could also just have a list of everything that it beats. And then you just say, okay, if the players didn't throw the same thing, then I'm going to look up what the player threw. And then I'm going to look and see if what the computer threw is in that list. And depending on how you set it up, if it's in there, either the computer won or the computer didn't win.
So you want us to change it?
Yeah, you can go ahead and change it.
And that reminds us when we were doing cases.
Right.
For
Make a list of users or
Oh, so you could say like when and then all the things that went.
No, you there. See the list on you.
Okay.
Yeah, it's just having a list of basically like, if you just have rock, you can have everything that beats rock in the list. So
Got it.
initially that's going to be paper, but for extending the game out to rock, paper, scissors, lizard, Spock, then it's like, I think Spock,
Redo all the code below.
you would have to redo everything that's handling that too. So it might not be worth redoing, because after this, I'm basically going to pull in I'm going to basically make one of these branches into the main,
Yeah,
and we'll start working on somebody else's code. So
okay,
yeah, what's probably going to happen is this branch will just sort of fall off, and then we'll resume on somebody else's code where we can build out from it. But otherwise, yeah, so you have it structured pretty well. You're getting the computer choice, you're getting the player choice. You have a function to play around here. One thing I would have is I would probably have it return something rather than just say whether it's a win or a lose. A lot of times you want your support packages to return something, not just print something. Or if they are printing something, that's all they do, because they're specifically to notify the user of something. But in this case, I'd have it return the result because, you know, like I said, we may want to build this into a little web server, and we'll be doing that tomorrow. You'll see how to build a web server out of it tomorrow. I'm not going to have you build the web server. I'll kind of show you how the code works for doing that, because building the web servers takes a few hours to learn. But you will have an example of how that works.
Oh, okay. So that's different, yeah. Okay. Thank you.
Got this. Thanks. I think it's Eloy's, but whatever.
Oh.
Oh, okay.
Yeah, thank you.
Okay, so I think based on what I'm seeing so far, it seems like the one that's probably working best is probably this one, which I guess is surprising because it has 3 people working on it instead of 2. So I think what we're going to do with this one, if you can put up all your latest changes, we'll make this one into the current branch, and we'll have everybody start working on modifying this one up. Okay, so did you push up all the current stuff?
Yeah.
Cool. Do you know how to do a pull request? So if you go, you might be able to do it on the desktop app. If not, you can do it on. If not, you can do it on GitHub.
Oh, you can do fetch origin.
The other thing is I can also just do it on here, because if nobody's done that before, reload this. I think I could pull request somebody else's. So yeah, new pull request. All right, so create the pull request. And it says here, okay, so wants to merge 3 commits onto main from this one. And in this case, since I am the owner, I get to just go ahead and merge.
So if we keep working on this branch, we'll just keep iterating on the branch and not on the main.
So the best thing to do right now, because there's been kind of there's basically been a version update. So the best thing to do right now would be to basically pull the latest main and then go back to main and then start a new branch off main. So for example, you might want to call yours just Michael Quentin 2 or something like that. And you can continue building off that. Everybody else should do the same thing now so that we're all working on the same code. And so for code, I'm going to go to the main branch, which I'm already on. And let's figure out what we need to do for the next hour or so. Yeah.
Is there any way embed automatically version in the source code?
To embed a what?
Embed the current version, current
Like the
branch or whatever you work with the code.
Oh, embedded into the
With SDN, like quick markers, where you can put a special thing, and then every time you get that, say it's a version or branch version, this is gonna be substituted or the branch version.
Quite possibly. I haven't actually looked into that because I usually don't use it. I usually just have a Python file called version info that I update manually. But there probably is, I just don't know about it. All right, so what do we have? We have our init file here. Okay, so the init file is empty, so we need to build out an init file. The init file is just going to import game and possibly whatever else we need. We have our play game file, and our play game file. So yeah, we're importing random. We have this type of data structure built up. We have our play game functionality, which is going to return P for player, C for computer, or T for tie. All right, so this is kind of our main function here. We probably want to move that up to the top level. Although actually I would say for this one, this is more of a determine winner function, I would say. This is more of the play game function, right?
Yeah.
So let's maybe just make this its own function for playing the game. That can probably just even return whatever this returns. And then we can get rid of the while true. So this will just play this function can just play one iteration of the game. So yeah, let's go ahead and do that. We'll have it do we'll have it basically and actually for this one we can even start breaking people up by sort of what they're working on. So yeah, if you two want to try doing stuff for If you want to make the init file for this, now that we know what's there, and then we can add to the init file as we get, if we get more. And then since you wrote this, I'll have you modify this to make that into a function that's going to basically, the input of this function is just going to be, well, this function will just run and yeah, right now this function will just run the game, so it shouldn't need to take any inputs. And it's just going to return, it'll return something to indicate who won. So the function at the top is going to be determine winner. The function at the bottom is going to be actually play an iteration of the game. And then we also need a top level function written, which I can have you guys do that one actually. And all that's going to do is, now that we know if the player wins, we get back a P, a capital P. If the computer wins, we get back a capital C. And if it's a tie, we get back a capital T. So if you guys can write a function in the top level that'll actually just call the play game function, then we should be able to actually work in parallel on 3 different parts. So, so these 4 will work on just getting the init file ready as it's needed. You'll do the modifications on here, and then they can do the top level function that basically runs the game like at the sort of, you know, on the main folder, like the main.py function, the main.py package. And we should be able to get it done fairly quickly, I think. Especially now that we know what's going in and out of each function. And remember to pull down the latest version and start a new branch.
What is your function gonna return?
You'll return P for like the player wins, C for the computer wins, and then T for the top. Isn't that what play game?
Yeah, you should probably work out what you're going to call that function between yourselves. That way they know what to call. But on the plus side, if you know what function to call and you know what it expects, which in this case probably it's going to expect nothing, and if you know what it returns, then they shouldn't actually need to see what you write to know how to call it and interact with it.
Yeah, you just call like
With no.
except give it the player.
We'll I think we'll make just call the second term player. Yeah, and then publish it. And we will have another. In here, so I think they just need to have this. So don't worry. Yeah, I guess.
Okay, so
All the way, and I'll give you this bank. So it just. Yeah, it's called play games. No frames. Yeah, no frames. So it's. So they live no frames. I guess you know what I just think about that as a simple rule.
So they call it.
Yeah. So whenever someone calls me. I have. So you're basically telling people. Yeah, ours.
Yeah.
So are you? So basically. Yeah, did that, they're returning history. No,
You'll figure it out soon.
Oh, correct. Yeah, but like if they have a. And then you can. Yeah, have to return this. No, I because I switched over.
So at this point, you're gonna work off of what they made.
So I guess.
Okay.
The result that. I guess they. Oh, that's from yours. I think they're. Yeah. Yeah, they have that.
Yeah.
Yeah.
It's gonna be made in directory. Yeah, main dot slide. And then they're gonna be yeah, and then just go to the brand, start setting that up, and then they're gonna be modifying theirs, so or you'll call what they have.
Oh,
So ideally, what you're doing is they want to.
okay, so make sure your current brand is. I don't want to be in main. Yeah. Yeah, so actually, before we do this.
You remember trying to keep things so as much as possible in function, so they can be pollinated rather than,
Okay.
after we rewrite it.
Those two, this one doesn't require any inputs, but we'll ask for entry. That doesn't have print. Okay. So we're giving, so they need to have like this, and then once it's called, they need to translate the piece. Yeah.
Also, keep in mind that keeping score wasn't necessarily something that was in the specs. So if we're not worried about keeping score, we don't need to write anything to handle that. I mean, you guys didn't have it in yours, but there were some other ones that I noticed did have a scorekeeper. So if you want to put in a scorekeeper, you can, but it's not necessary.
And so like actually. I guess then you guys can like, you know, how many things you want to play. Yeah. Yeah, I'm just putting it on. Again, you don't have to. Yeah. So yeah, so now that should go good. So if we go to the. Or you want to go back? Yeah, I want to go to the. I guess this is. I mean, to the browser. Maybe I can just look at the name. On my computer. Yeah. Look in there. Yeah. So we did it. So we have to commit. So what is just syncing it with the. So yeah. So you basically make sure you're the right branch into ours. If you pull it, you basically just override whatever's on your directory at the moment, with the exception of like maybe some changes you think, because like we'd already changed it to .5. So knew that and then save that, but it's sort of it's smart. Like I'm not an expert in calling the algorithm to the users, but it'll just pull the copy of the main branch onto your computer, but it also preserves like changes you made relative to the main branch. Like it preserves the init.5 change you made. And then you overwrite it. So then that makes sure that you're just all synced up with the right branch, and then you can make whatever things you want, and then push just everything back into the
Yeah, although something to keep in mind is that's a good reason not to make changes even on your own local system domain. Because when you pull down origin, unless you specifically tell it pull down origin and get rid of anything that's not origin on mine, you're going to have a different version of main than everybody else. Which means that when you make your branch to make your modifications, you're going to be working on, again, a different version of main than everyone else. And that's going to cause problems. So that's a good reason to always try and keep your main branch protected and make sure that make sure that you have the same main as everybody else working on the project.
I don't think it'll be an issue for us. I think just change one line. I mean, normally we would create our own.
So yeah, you do want to create your own branch here. Because again, you'll have a slightly different version of main. And when you try and actually do a commit and push, that means you're modifying directly on the origins main. And that's usually going to get kicked back. Because a lot of people don't like committing directly to main. Now, in this situation, I probably would actually commit that directly to main if I was working if this was a real project, because what you're doing is a minor thing. But for the purposes of this one, we're not going to do that. So yeah, for the purpose of this one, did you already commit the stuff you wrote?
Yeah. Okay.
Okay, yeah. So you might want to. Yeah, you might want to make another branch and commit it, but you also want to roll back your last commit so that you are back to like the official version of main.
Like, is there an easy way to roll back, or do we just delete the changes?
The easy way to do it, I think I don't remember how to do it on the command line, but in the desktop, you should have a pretty easy option to see old commits and just to basically select an old commit and say, go back to that state.
Well, make sure it's the right. Okay. Because it shows whatever branch. Yeah, that's the right. Okay. So
Yeah. One thing to do before you actually roll it back. One thing to do before you roll it back, if you haven't already done so, if you just copy the line to the clipboard, you can always just put it back in on a new branch.
Oh, like that.
Yeah. On the other hand, you can always retype it as one line.
So you mean, yeah, so now what you need to do is you need to push. So click on that. You already mentioned. No, then you have to push the origin. Oh, let's bring up.
Wait, what are you pushing to origin?
The revert.
Oh, did you push the new commit to origin already?
Yeah.
Oh, okay, yeah.
Yeah. I think it should be. Yeah, so. Just go back. I mean, you should be able to. It's like Logan.
Yes.
What's the difference origin and then main? So main is a branch, but it's like fetch origin. Yeah.
So origin is actually the central repository. So that's like the GitHub. That's the one that everybody's sort of coming out from. Main is just that's the branch that's in production.
Got it.
And it doesn't have to be called main, it can be called other things. But origin is a specific term for where you got for like the central Git server.
So make sure that you save that. Okay, now go back to your desktop. The Git desktop. And what you're going to do is change your, okay, good, we're in the right branch, so now publish that branch.
I also have another question.
Yeah.
So if
Now.
so if you have to pull from main again, there's not the changes made, but in your branch, there are still some adjustments made to the scripts that you want to carry over into your new branch from the updated main. Is there an efficient way to do that, or is there like a way to?
It probably is, but that's going to get very confusing very quickly. So what I recommend is just honestly what I recommend there is just copy pasting stuff if you need to. That's going to be much simpler than having like a very layered branch structure. Yeah, I mean there are ways to do it, but I'd say that for later when you need to start learning those things. Especially for a smaller project, you really shouldn't be doing that because that's going to get confusing.
I kind of understand.
Hmm? Yeah, I know. After class, I'm going to get an espresso.
I need to go 1 hour nap.
I can at least enjoy my coffee again now that my sense of taste is returning.
Have that.
I am like the stereotypical case of I have a super good immune response to it,
Yeah,
but just like a lot of the other people who have a super good immune response to it,
yeah.
it just immediately knocks out my sense of smell, like complete loss of smell.
Yeah.
When did you get it again?
I guess 2 weeks ago.
Okay.
Oh,
Right
oh, you
after
just had it.
Yeah, and
We'll still get it.
so actually the weird thing is it hit my father-in-law, it hit my wife. She's like still coughing like crazy.
Yeah.
It hit my daughter, but I think she just got like snotty. And she's 2.
Yeah.
This was like all of us getting it for the second time. And she did all right. The funny thing is, whatever strain it was, is one of the ones that is absolutely not detectable by the antigen test.
Oh,
Like among the family, we had like, I think 7 negative antigen tests
oh, wow.
while people were actively sick.
Yeah.
And the only reason we figured out, the only reason we figured out it was COVID again was no, because weirdly enough, I wasn't even sure I didn't have allergies until I was like, okay, my nose is clearing up, but now I can't smell anything. Oh crap, I know what this is.
Yeah, I thought it was just allergies again too. And then it wasn't.
Yeah.
I had the Florida version of Omicron. Yeah. There was like a, no, it actually, there was like, my dad was in Florida, it's really very tragic, but, there was like a huge, so I visited him, for Christmas, and there was a huge outbreak there, we were really careful, but I guess not careful enough, and I got it. And it was like nothing. I didn't lose my smell and taste or anything, it was crazy.
What'd you get? Did you just no symptoms or
Like, yeah.
you just got a positive test and nothing else?
I had a little bit of a stuffy nose, and so I was going to visit my mom, her husband is older, and so I tested. So I'm trying to be safe. Really wasn't bad. I had the flu A, and that was really crazy. I had that scare. It was really rough. But I know a lot of people that COVID really. I think the Florida Omicron. It's really viral, but not super.
If somebody using that. Yeah, no, for me, yeah. No, for me, it was like, I was barely symptomatic and I would have had no idea that I had it, except that it's like, one morning I was like, I can't smell my shampoo.
There you go.
And then I go downstairs and like smell my coffee can. It's like, yeah, I can stick my nose right in this coffee can. I don't smell anything.
wow.
So it's like, okay, there's only one thing that ever like, not even like the worst allergies will make me lose my smell. So like, I can't smell coffee. On the plus side, if you want to see kind of a cool thing in my GitHub, it's either in my GitHub or my old employer's GitHub, but I have code in there that actually caused a COVID spike in California. if you look for a program called Zymo Transmit, it's something I wrote that actually caused it caused COVID to spike 1 weekend in California because of it. All right, so how's everybody doing so far? Good.
Yeah, I think we made our last. We made our last changes.
Oh, cool. Did you push them?
Yeah.
Okay, excellent. So let's go to, let's reload the page. All right, so for gameplay now we have a determine winner function that takes in the player throw and the computer throw. Awesome. It also takes in the rule dict. Yep. One thing, and I'm not going to worry too much about it right now, but you might see me just sort of add this in tonight as a last minute change, is I'll show you how to add in using the typing library, what to expect in the dictionary. We have a play game function here, and this one will actually run the game, which is going to set up the rule dictionary. It's going to take in the player throw. It's going to take in the compute. It's going to get the computer throw.
This could be extended input that is putting a from something direct from the from
What's that?
If this thing is supposed to be extendable, instead of listing explicit raw paper or scissors, I would read the thing of the keys from the dictionary.
Yes. So yeah, that's something I might throw in here, and that's actually a functionality that that's going to be worth building in. And just for user interface, rather than having people type in rock, paper, or scissors, what if you just have it build up another dictionary on the fly that is, press 1 for rock, 2 for scissors, 3 for paper.
Check for the start.
Yeah. Or have them put in like RPS or something like that. So yeah, that's.
And also push down the case, push the upper, lower, whatever is typed, so it is not case sensitive.
Possibly. That's where having them put in numbers really helps.
Yeah.
So yeah, we have a pretty good structure here. This should work. Like I said, I'll usually go in here and do like a commit later and just make a few and just sort of like polish up a few things myself, so you can kind of see, these are some good foundations for building up later. But yeah, so we have this built up.
Oh, then I would put another second. I would put the rule dictionary completely in the top level.
What?
I would put the rule dictionary completely at the top level and pass it as argument.
Yes, I would. Yeah, I would put the rule dictionary as its own thing, or at least as its own function, because you might want to still keep a rule dictionary for rock, paper, scissors, but you might want to keep a second one for rock, paper, scissors, lizard, Spock. And then that way, at some point, the program can just say which dictionary it's going to use. So in theory, you could switch between games just by switching between dictionaries. All right, so we have that one. I think that one's good to go. So with this one, I would say this main should probably be moved up to the top level folder.
Okay.
But I will have a quick look at it. So yeah, import play game. So actually, you're going to import just the whole RPS support package, because you're going to be importing from the top level. Basically, the entire support package exists to kind of support stuff in here and keep this part relatively clean. All right, so we have that.
think just.
Oh, yours is called a init file, yes. Yep, you're importing play game, okay. All right, and it looks like you already put in the pull request for yours.
I don't think we did. I don't think we did.
Okay, so this group and this group put in pull, you can both put in pull requests for yours. And then as soon as you have yours moved up to the top level, put in a pull request for yours, and we can start merging them on. Although actually, Miranda, it looks like you do have that already up.
I don't know what I was doing.
Okay, well, no, it says Miranda's son wants to commit, wants to merge one commit. So yeah,
So like, that's what we want to be doing right now. Is what you're saying.
yes, so it says you want to merge, yeah, you want to merge one commit onto main from init file, right?
Yes.
And there's only one commit that you did, right? So yeah, even though you didn't know what you were doing, you did the right thing apparently. Yeah.
Which I think this is a good chance. Oh. Oh, maybe so, no, because you're doing your choosing branch into the Git file, not main. Like, oh, yeah, so we have to go to the main.
Okay, yeah, I mean, this merge just has the init file in it, so we're good.
Yeah, but you might not want to do that because it might just merge it without doing the pull request. Because the pull request requires his approval. Like, I think we have the ability to merge stuff in the main if we want.
Yeah.
But we don't want to do that. We want.
So normally you should not be able to merge stuff directly into main. I didn't do a protect on the main branch here, but I could do a protect on the main branch, in which case it actually would disallow you. But it would also cause a bunch of errors to pop up, because if you accidentally tried to merge onto main, you get a very angry set of messages from GitHub. If you're in somewhere like a clinic, for example, where you actually, if you're in a clinic that's doing NGS work and you have like your scripts and your bioinformatics pipelines, a lot of times the main branch is actually owned by somebody in your quality control.
Yeah.
At least in terms of somebody from quality control is the only one who actually can approve merging onto it.
So we can't do the pull request on the GitHub desktop or
Sure you can.
because we can't find one. When I put the help, it just sent me back to the website. So
Oh, okay, well, she actually got it though. She got what she needed.
Yeah.
Yeah, that's perfectly fine too. I used to do pull requests on GitHub too, because a pull request is actually not a standard part of Git. It's part of GitHub, but it's not a standard Git functionality. Merge is a standard part of, like, it's a core functionality of Git. Pull request is very specific to GitHub. And in fact, pull requests on GitHub, you'll typically even do that with not just branches, but what they call forks, which is you made your own copy of the entire repository. So anyway, oh, good. All right, so let's get this one. going to drag this to my screen for a minute because this is really hard to fix on that viewing. Okay. Occasionally get merge conflicts. Was not expecting to get one here. Oh, I see where that happened. Okay. Okay, so that one got merged. Yeah, it had a weird thing going on where it thought you put something in the middle of something else where you clearly didn't. So it took a second to get that sorted. Okay, so this one merges automatically because it's touching a file that isn't already touched. All right, and this one. Let's just give this one a quick review. Okay, it looks like you actually merged main. It looks like you merged directly onto main.
Yeah.
So yeah, so generally don't do that, but in this case it's fine because I would have done it anyway. And then and then we still have that in there. So let's merge. Okay, I see why it looks like that.
Yeah, that one's just to get rid of the redundant thing.
Okay, so we've built out what should be a version 1. Obviously, I recommend everybody actually try and run it, see how it works and everything. And then let's see if people can get it to run or what errors we're getting. So now we have a version, we can start doing some bug checks, but in theory, we have, once we fixed any bugs with this, we kind of have our minimum product, right? Like we have a rock, paper, scissors game. So pull down the latest from main, try and run main and see if you get errors. All right, what error did you get?
So in the main, the first line is import play game.
It should be import RPS or
Yeah.
All right, so you should be able to fix that. In fact, your IDE should pretty much detect it.
following.
All right, so yeah, you can, if you make the appropriate changes, then you should be able to see what, what works or breaks after that. But at this point, we're basically just bug fixing. All right, what error did you encounter now?
So.
What does the error message say?
So the first one is that, in the main file. You have to input the number of games you want to play, but that input is interpreted as a string. And so then there's a loop going on with the string, but you have to convert it to an integer first. So.
Okay, so we had a little bit of a bug there.
And then after that, there's the RPS with which
Oh, that's probably because it's calling RPS support module, but not the specific play game function. It's probably not calling the function.
right.
That's exactly what would happen if you forget to change the name when you move it. All right, I think I can get everyone out of here around 11:30 if people want to try and get to lunch without having to deal with lines. What? Oh, you gotta take off anyway? Okay, yeah, go take a nap and have some coffee. Yep. All right, so yeah, I think I get us out of here around 11:30 or so. But yeah, I think at this point, everybody's probably sort of picked up on what needs to be done. And if you have changes, probably a little bit after lunch, I'll go through them and see what people have suggested. And then basically after I take the next round of changes in, I'll just go over, kind of polish it up so that we're ready to make further updates tomorrow to extend the program more. All right, so with that, I'm going to stop the share, and I'm going to end the online portion.